Right, notes 2.3 are on solving multivariable equations for a single variable. Now this is going to seem a little strange to you at first, but once you realize that it's just like solving any equation, it's not bad at all. So if you look in the box that's on the top of your paper, there's a standard equation on the left side. Please press pause and solve this equation and then come back to me when you are done. All right, go ahead and look at the work that we have here. If you need to press pause to make sure that you understand this, go ahead and do so. All right, so now we're going to look at our literal equation. Now, a literal equation is just a standard equation that might have some variables in it, more than one variable that we're trying to get by itself. So if you notice right here, it says solve 2x plus 3 equals 9 for x. Here it says solve ax plus b equals c for x. Now, the x is the variable that we tried to get by itself in the standard equation, and it's the same variable we're going to try to get by itself in the literal equation. So here, see how you have a 2? It's like the A. The B is like the 3, and the C is like the 9, okay? So, right here, do you guys see how we got rid of the 3 by subtracting 3 from both sides, okay? Here, we're going to do the same thing. We're going to get rid of the B. So to get rid of the B, I'm going to subtract B from both sides. Now, the difference between this equation and this equation is that 9 and negative 3 were like terms, so we could combine them and say it's 6. Here, C and B are not like terms, so we can't combine them. So our answer, not our answer, but the result in this step would be C minus B. Now, all I have to do, just like we got rid of the 2 by dividing by 2 because it's 2 times x, I'm going to get rid of the a by dividing by a since it's a times x, which means that my answer is x equals C minus B all over a. All right, so let's look at number 1. In number 1, it says that the equation is d equals RT. So that's my equation right here. The semicolon followed by the r just means that the r is what we want to get by itself. So here, if I want to get this r by itself, I need to get rid of the t. Well, r and t are stuck together by multiplication. So to get rid of the t, I'm going to do the inverse of multiplication, which is division. So I'm going to divide both sides by t. So that means that r equals d over t. All right, so in question number 2, same thing. I've got another equation and I want to get the t by itself. Excuse me, I want to get the r by itself. So in order to get the r by itself, I have to see what's on the same side as the r that I want to get rid of. Well, it's being divided by t, so the opposite of division is multiplication. So I'm just going to multiply both sides by t. This t and this t will cancel each other out, so I have a times t, or t times a, because the distributive property says you're allowed to do it in any order you want, is equal to r. The r is completely by itself, and I am done with that problem. All right, and number 3, it doesn't tell you what variable to get by itself, so I will tell you that the variable that we want to get by itself is the r. So r is what we're going to try to isolate or get by itself. So this has 2 steps. First thing I'm going to do to get rid of to get the r by itself is get rid of the 6. So I'm going to subtract 6 from both sides, and I end up getting 5r equals s minus 6. The last step that I need to do is divide both sides by 5 to get that r by itself. So that means that r is equal to s minus 6 over 5. Now, neither of these numbers is divisible by 5, so I'm not going to do anything else to simplify it. This is it. All right? Now let's take a look at question number 4. Number 4 is a little tricky, so make sure you guys are paying extra close attention to this. So in this problem, I want to get the h by itself. So it's 1/2 times b1 plus b2 times h. So my goal is to get this h by itself. Every time you have fractions, get rid of them completely to begin with. Now, if you guys notice, this is all one term because it's all separated by multiplication. So when I get rid of this 1/2, by doing the opposite, multiplying by 2, I only need to do it once because, again, this is all one term. If there's more than one term, then you have to do it to each term. Whatever I do to one side, I do to the other side. The other side only has one term as well, so I only multiply by 2 once on the other side. The 2's on this side cancel each other out. I have a 1 left over, but 1 times anything is itself, so I don't have to really write it down. So on the right side, I end up getting b1 plus b2 times h, okay? And then I have 2a on the left side, okay? Last thing I need to do is divide both sides by b1 plus b2, okay? Because this is separated by multiplication. So these b1 and b2s will cancel each other out. So that means that my final answer is h equals 2a over b1 plus b2. Okay, sorry about that. All right, so now let's take a look at number 5. In number 5, this is a little tricky. So I want to get the e by itself, but the e is in a fraction, and all of these numbers are fractions right here. But it's really technically a proportion, so I can just cross multiply. So 9 times h is easy, that's 9h, okay? But then 7 times e plus f, you have to be really careful about how you write this out. It's 7 times the entire e plus f, so you must distribute here, okay? So then I have two choices. I could distribute, right, to get the parentheses out of there to help me get the e by itself. But really, if I want to get the e by itself, I could just divide both sides by 7, and then my e plus f is isolated, which helps me get the e by itself. So I get 9h over 7 equals e plus f. Now, last thing I need to do is get rid of the f by subtracting f from both sides, okay? But this is a fraction right here, so I get 9h over 7 minus all of f is equal to e, and then I'm good to go. Okay? All right, last one. Question number 6. So in number 6, I'm trying to get the h by itself, okay? So I'm going to copy down the problem. And remember, we said we want to get rid of our fractions first. So again, this is all just one term because it's all separated by multiplication. There's no addition or subtraction signs here. So I'm going to multiply by 3 just once on this side and once on this side. So these 3's will cancel each other out. Remember, you multiply by however many terms there are. Here there's 2 terms, one on each side. So I get 3v equals pi r squared h. Now again, my goal is to get the h by itself. So I can divide both sides by pi r squared because this pi will cancel out and the r squared will cancel each other out, right? And you know what? I'm sorry, the way I canceled that out doesn't look proper. The r squared goes away with all of the r squared, okay? It's not the r separately from the squared, okay? Divide both sides by pi r squared. You end up getting 3v over pi r squared is equal to h. So the h is isolated. All right? Again, I know this is a little weird, but the more practice you get with it, the less weird it's going to be, and pretty soon you'll be able to do this without any difficulty.